Part 2 of this paper, it says Keris makes hats for a living. Each hat she makes needs 0.45 metres squared of fabric, costing £3.40 per metre squared, and 50 centimetres of ribbon. She pays herself £12.60 per hour. She can make 3 hats in 2 hours. There are no other outgoings. She sells each hat for £10.25, which exactly balances. So she's exactly balances the cost of her outgoings. So she doesn't make any profit. She doesn't lose any extra money. So it's going to come to zero. Let's calculate how much the ribbon costs per metre. And they just said centimetres there, and they want this per metre. So maybe we could work in 0.5 metres here. We'll see at the end. So each hat she needs 0.5 metres cubed of fabric, costing £3.40 per metre squared. So each hat she makes 0.45. She makes 3 hats in 2 hours. So it says there are no other outgoings. She pays herself £12.60. So she works 2 hours. 2 hours times by £12.60 per hour will tell me exactly how much she earns. So you could do this in your head, but it's probably not worth it if you have a calculator. Just double check and make sure you've got the right answer. So she pays herself £25.20 is paid to, what's her name, Keris. Okay. She sells each hat for £10.25. So she sells 3 hats. So 3 times by £10.25 equals £30 and 75 pence, which is total making, or total price she receives. So that gives me a difference here of £30.75 take away the £25.20. So the difference is equal to £30.75 take away £25.20, which comes to an answer of £5.55. Now that would have to account for just the ribbon, I believe, and we know that each hat uses 50 centimetres of ribbon. So we know this would be the price of the ribbon for 3 hats. So 1 hat makes 50 centimetres. We've said that already. So 3 hats, so 3 times by 0.5 would be 1.5 metres of ribbon in total. And that means the 1.5 metres of ribbon is equal to the £5.55. Now I'm asked to go and calculate how much the ribbon costs per metre, so I need to change that into 1. So the best way to do that is to divide both sides by 1.5, because 1.5 divided by 1.5 will be 1 metre, and then 555 divided by 1.5 comes to 3.7, which would be £3.70 for a metre of ribbon. Next question. Factorize the following expressions. Can't really see this coming up, but I will go through it very quickly. 6 and 12, biggest number that goes into that is 6. X cubed and x squared, so the biggest letter that goes into that is x squared. And then 6x squared times what makes 6x cubed? Well, the answer is x. Minus sign then, and then 6 times what makes 12, so 2, and the x squared is already there. So that's that factorized. This one here will be a double bracket. We are looking for 2 numbers that times together to make 42, or minus 42, so that means it must be 1 of each sign, so they times together to make a minus, and they add up to minus 1, so that would be plus 6 and minus 7. To do this one here, you would do 15 times by 14. So 15 times by 14 comes to 210. They add up to make 31. So I'm thinking of what pair of numbers times to 210 and add to 31. So there's loads of different combinations, no doubt, that you could get, but you may be really lucky and just spot it straight away, and I think it's that. 21 times 10 would make 210, they add up to 31. So the way I factorise, and you can do it in a different way, it's fine if you want to do it a different way, is I just drop the squared from 15x squared and put it in both brackets and chuck in both of these numbers here. But then if you use this method, you must cancel down by the biggest factor. So 3 goes into both of those, so that becomes 5x plus 7, and then 5 goes into both of those to give me 2x plus, sorry, that's a light, 3x plus 2. And then check, doing 5x times 3x makes 15x squared, plus 7 times plus 2 makes plus 14. Over the page, solve this equation. So expand that out, we're going to get 5x plus 5. And then you want to get the x's on one side, ideally not negative, everything else on the other side. So I'm going to have the plus 5 here. I'm going to take this plus 5 over, and it'll become minus 5. I'm going to have 5x minus 2x. That's going to give me 0 equals 3x, and then 0 divided by 3 is equal to x. So x actually equals 0 in this case. This one here, I don't like this third bit, so I'm going to times absolutely everything by 3. Now that means I have to times that by 3, that by 3, and that by 3. So it's going to give me 2x plus 3 plus 12x is equal to 24. Okay? For instance, an example of why this works is something like 2 add 3 equals 5. That statement's true. If I times absolutely everything by 3, I get 6 plus 9 is equal to 15. And check, 6 plus 9 is equal to 15. So as long as you times every single bit by that, you will get the same answer. Okay? I'm now going to collect the x term, so I'm going to get 14x, and I'm going to take this plus 3 over to the other side, where it will become a minus 3 to get 14x equals 21. And then x equals 21 over 14, which I'll chuck into the calculator. 21 over 14 comes to 3 over 2. Now there's a very clever way that I can check to see if that's true. I can chuck in that as my x. So I'm going to say a third bracket, and then 2 ands. I'm replacing x for ands because I know that's 3 over 2. Plus 3, and then plus 4 ands. And that answer should come to 8. And it does come to 8, so I'm definitely right. Over the page, we've got some triangles here. This wants to know all 3 sides. It's a right angle triangle. That is telling you to use Pythagoras Theorem, which is a squared plus b squared equals, I tend to use the letter h squared, but you can put any letter there you want. Most people like to put a c there. Because I know the hypotenuse, I'm actually going to do the hypotenuse squared, take away the other one squared to equal the other one squared. So that will be 56.2 squared minus 12.7 squared to equal w squared, because they said it's w. I will then find out what that is. So 56.2 squared minus 12.7 squared, which comes to this number here, but I'm going to take the squared over at the same time and make that a square root. So it's 2997.15. So square root of that answer comes to 54.7 to 1 dp, but I do need to reference that to 1 dp. This question here is a right angle triangle. It wants me to find an angle, so I'm going to use SOHCAHTOA. This is the hypotenuse. Because this is the angle, this is opposite it, and this is the adjacent. I know the hypotenuse and I know the opposite, so when I write out the word SOHCAHTOA, I'm going to tick off O and H. The one that is double underlined is the one I will use. So that is sine angle. I say sine theta is equal to the opposite, so 14.2, divided by the hypotenuse, divided by 34.6. So theta is going to equal to sine minus 1. When sine goes over the equal sign, it changes to sine minus 1, of 14.2 over 34.6. So sine minus 1, 14.2, 34.6 goes into my calculator, and I get 24.2 degrees to 1 decimal place. Over the page, similar triangles. I'm going to look for the scale factor here, which I'm going to call SF. The way I do that is I look for corresponding sides which I know both of. I know the base, and I know the base of that one. So to work out the scale factor, you do 46.2 divided by 8.4. That comes to 11 over 2, which is 5.5. That means I'm timesing by 5.5 to make the small one into the big one, and to change it backwards, I'm dividing by 5.5. So to work out what x is, I want to do 10 times by 5.5, which is equal to 55, so x equals 55 centimetres. To work out what y is, I need to do 18.7 divided by 5.5, so 18.7 divided by 5.5 comes to 3.4. So 3.4, y is equal to 3.4 centimetres. Over the page, it says select two pairs of congruent triangles. Give reasons why each pair of triangles are congruent. Okay, so there are types of triangles that we need to know, which are SAS, ASA, and right hand side and side. Okay, they're my conditions. So I'm looking for ones that have all the same sides, and they've got to be touch each other there. 4.2, yeah, 6. Yeah, that one there. So D and F. D and F is congruent because all the sides are the same. Okay, so I'm just going to tick those so I know them. Now these two here are not congruent because all the angles are the same, but I could have a triangle that's much larger with exactly the same angles, and it doesn't mean that I can physically pick it up and put it on the other one. That's what congruent means, that I can pick it up and put it on the other one. Okay, so if I was to choose another one here, that's 4.6 and that's 4.6, but more importantly, it includes the 80, which is exactly what this means. Side included angle and side. That's what SAS stands for, and I can see that's the same one there. So C and E are congruent because it has side, and then ideally you put in the word included angle side. Okay, that's the reason why it's congruent. Over the page, cumulative frequency, I'm actually going to skip because it was in Wednesday's paper. This question here I'm going to skip because I don't believe it would come up in the numeracy paper. And the same as that, it's related to the last question. This one here could come up. It says 50 people took part in a charity walk. The table shows the grouped frequency distribution for the amounts of money. Calculate an estimate for the mean. So between 10 and 19 quid, 2 people raised that amount. So we're going to take a guess of what it is. So we take that as the midpoint. What's in the middle of 10 and 19? If you don't know, the best thing to do is to add the two numbers together, find out what that answer is and halve it. And the answer is 14.5. And it will work repeatedly every time you do that. Add the top and the end number, press equals, and then divide by 2. But I can spot them, so I'm just going to carry on writing them in. Underneath the midpoint column, I'd recommend shading out so you don't accidentally add that up. You create another column, which we will eventually add up, called midpoint times frequency. So 14.5 times 2, which is 29. 24.5 times 18, which is 441. 34.5 times 29, which is 1,000.5. And then 44.5 times 1, which is 44.5. We're going to add up all of these numbers, but they may tell you in the question exactly how many that were. So 50. And then 29 plus 441 plus that answer plus the 44.5 comes to 1,515. So the estimate for the mean would be the 1,115 divided by 50. So that answer divided by 50 comes to 30.3, but because it's money, you put it to 2 decimal places, so £30 and 30 pence. So histograms I'm going to miss because it came up. This one here I'm going to do though, proportionality. G is directly proportional to t squared. So we write that like that. If it said inversely proportional, I would have said 1 over t squared, but it doesn't. So I'm going to say G, I change this fish symbol, changes to equals k. So that becomes equals kt squared. I'm now going to chuck in the numbers that I'm told. So G, 450 is equal to k, and then t squared is 7.5 squared. I'm now going to bring this times by 7.5 squared over to the other side and divide by 7.5 squared to find out what k is. So 450 over 7.5 squared. That comes to 8. I now write k back into this line here to get my final third mark. So it would be 8t squared. Okay? To work out this one, it says find out the missing places. So G, but I know T is 2.5, so I do 8 times 2.5 squared, and that number comes to 50. This one's not quite as simple because I know G this time, so it would be 800 is equal to 8t squared. So I'm going to take the 8 over to divide, and that will become t squared equals 100, and then I'll square root 100 to get t is equal to 10. Over the page, I crossed this out originally and I thought, no, you know what, it says it's about a surveyor measuring some field on a sketch, so this could come up. It says calculate the length of A to D. So that's this line here. Now, I know a side and I know an angle. That's not enough for me to work out anything here. They're non-right angle triangles, so I'm going to be using sine or cosine rule. Maybe both. Probably both if it's worth 7 marks like it is here. Okay? Now, I can work out this length here if I look at the top triangle, because I've got 2 sides and 1 side there, and I want to find this side here. So I'm going to call that little b because it's opposite capital B. I'm going to call that little c because it's opposite capital C, and I have both of those angles. Using the formula sheet, I know that I'd say little b over sine b is equal to little c over sine c. I'm now going to substitute that information in to get little b over sine 49 is equal to little c, which I know is 142, over sine 62. I'm now going to bring this divide by sine 49 over to the other side and say 142 over sine 62 times by sine 49 to work out what b is. The way I tend to write that into my calculator is as follows. 142 times in by sine 49 just times is the numerator, but you can write it the way I've written by the side there. It makes absolutely no difference. And then press equals, and I find out that b is equal to 121.37 blah blah blah. I do not round that answer because I'm not finished yet, but I do know what this is now. Okay? So to work out this side here, I know 2 sides and an angle, and I want to know a third side. That is telling me to use the cosine rule. Now if this is capital C here, this would be little c by here. This would be little b, but also little d in the bottom triangle. And then this side here would be little a. Now the cosine rule says a squared equals b squared plus c squared minus 2bc cos capital A. And that's because in their rule, they actually have the capital A. I have capital C. If I have capital C, I'm going to end up having cos C at the end, which means I have to have little c at the front. And then that would be equal to the other 2 squared. So it would be little a squared plus d squared minus 2ad cos c. I'm now going to substitute that information in to get 224 squared plus, and then it's going to be 121 point blah 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 squared minus 224, and then 121, and then cos capital C is 74. And that is going to go into my calculator. So 224 squared plus, so I just do the next one as plus and squared, minus 2 brackets 224, then ands, and then cos 74, close my bracket, comes to an absolutely massive number. You may be thinking, well, there's no way it can be that, and you're right, it can't be that because it's way too big, it's c squared. So we now square root that answer, and we get the answer 223.4 centimetres, or meters, because it's in meters, to 1 decimal place. Over the page, last question. I don't really think this will come up, but I will show it very quickly. It says cos x equals 0.342. You find 0.342 roughly on here, so roughly about there, 0.342. You draw a line from that point, it will hit the graph twice. It will hit here, and it will hit here. You will then solve this equation. You will take cos over to the other side, and it will become cos to the minus 1 of 0.342. So I put that into my calculator and get cos to the minus 1 of 0.342 that is, sorry, and that comes to 70. That's this answer here. That answer there is 70 degrees, but there's also another answer in the range from 0 to 360. There is a line of symmetry here. I've come in 70 degrees from here, which means I want to come back 70 degrees here. So we do 360 minus 70, which gives me the answer 290 degrees, and that is that paper finished.